type test, routine test, and special tests. Impedance voltage test, or the percentage impedance. The results taken from the factory or from the site. They are themselves insulated. They are also separated by insulator polarization component. Any insulation material is hygroscopic in nature. The high voltage windings are connected to the tap changer, which has tabs. Bismillah ar-Rahman ar-Rahim. After the transformer gets completely manufactured, it has to undergo a sequence of tests. Some of these tests carried at the manufacturer premises in the factory. Some of them are carried in international institution or international certified laboratory, or at the purchaser premises after delivery of the transformer, and also on a frequent basis for preventive maintenance. All of these tests can be classified into three main categories: type test, routine test, and special tests. We are going to discuss these tests from different perspectives, not in an educational, formal way, but from the physical meaning point of view. Why do we do these tests in the first place? And what information does this test give to us? What are the benefits from these tests? And what will happen if we do not do these tests? These tests will take care of most of the transformer parts, and with the special tests, each single component of the transformer can be tested. Transformer has two major parts, as we said: active parts and passive parts. Active parts are the winding and the core. Passive parts are the tank, the oil, the pressure relief valve, the tap changer, oil level indicator, thermometer, etc. Let's take the windings, for example. We can test the winding resistance. We can test the insulation of these windings. For the core, we can test the magnetic balance. For the oil, we can test the breakdown voltage of the oil. We can take sample from this oil and see the details of the ingredients of the oil. If some other strange particles are there, we can discover them by taking sample and analyze it in the laboratory. Some of the tests carried out on transformer are the winding resistance test, insulation test, magnetic balance test, vector group test, oil breakdown voltage test, high voltage test, basic impulse level test, impedance voltage test, or the percentage impedance, and so on. We will be discussing these tests from the practical point of view. We will see the results taken from the factory or from the site with practical figures. We'll start with the routine tests. There are up to 10 tests which are considered a routine test. Routine tests shall be carried out for each single transformer, and then 2 or more tests will be added to this routine test. For the type test will be carried for a single unit, a sample unit, to prove the design criteria. And then after type test, we'll be moving to special tests. Special tests are based on the customer requirements. Some customers need some additional tests to be carried out, like noise level test or partial discharge test. We will be discussing these tests from the practical point of view, focusing on the physical meaning of these tests. We will be studying these tests one by one. For each test, we will define the test in a simplified wording, mentioning the reasons to do such test, the equipment used in this test, the connection diagram for the 3-phase distribution transformer, and you will see practical results taken from the factories and on site for these tests, and we will explain these results in a very simplified, practical way. In this episode, we will discuss the insulation resistance test and each other test we'll have a dedicated episode later. At the beginning, let's define what is meant by insulation. What does the word insulation mean in electrical system? Before, there was an episode about the insulation materials used in fabrication of the transformer, like the paper, the wood, the oil, and it was mentioned that the science of insulation materials is much wider than the science of conducting materials. For an electrical engineer who studies the conductors like copper and aluminum, their chemistry and their physics, he has also to understand the physics and chemistry of insulation materials. And it's very important to understand these insulation materials for the safety of the personnel and also the safety of the electrical systems. In any electrical system, equipment or device or whatever, the system from the electric current point of view can be divided into two main components. One of them is current carrying components and the other is non-current carrying components. This non-current carrying component is divided also in two parts. One of them insulation materials, which are by nature do not conduct electricity. The other is conductive materials like metallic materials, but they are not supposed to carry current. They are supposed to form the structure of the electrical system and not to receive any electric current. For example, if we take an electric cable, this electric cable has the conducting element, which is the copper conductor. Sometimes it will be aluminum. And this copper conductor has an insulation, XLPE or PVC or rubber or any plastic material, and also another filler insulator. After that, there is steel wire armor. Steel wire armor is meant for mechanical protection. It's not supposed to receive or conduct current. So this insulator is acting as a separator between the current carrying conductor, the copper, and this steel wire armor. Also, this cable may be laid on a cable tray, which is metallic, can conduct current, but also this insulator with the outer sheet make a barrier between the current carrying conductor and the containment, the cable trays housing or supporting the cable. Also, the distribution board in your house. If you open the door of the distribution board, you will see addressed wires for all the circuits fixed on the back plate of this distribution board. This back plate is metallic, the housing itself, the enclosure, is metallic, and this wire which conducts electricity, the copper conductor, is isolated from the back plate and the enclosure by this insulator. The socket outlet also in your house. If you open this socket, you will find inside the wires coming from the distribution board to this outlet. These wires are PVC insulated. They are in touch with the GI back box, which is metallic. If there is a failure in the insulation materials, maybe by the technician during installation, this will bring the conducting copper, conducting wire in touch with the back plate, which will be dangerous for both the electrical installation and for a human using this outlet. This can be generalized for electrical equipment and system, for the generator, for the electric motor, and for the distribution transformer, oil-filled distribution transformer. We saw how this transformer was manufactured step by step and how the insulation materials are used in this transformer. Starting from the windings themselves, whether the low voltage or the high voltage, wires or copper foils, they are themselves insulated, also separated by insulator, papers and woods, and they are inside the tank immersed in the oil. Oil will provide more insulation resistance required for this transformer. In electrical system, insulation materials like glass, wood, plastic, rubber, porcelain, whatever, they show high resistance for electric current. In the perfect world, this insulation materials shall not conduct any electric current, zero. But in the real world, things are different. There is a current flowing in this insulation materials. It's very tiny, in the range of milliamps, microamps, or even nanoamps, but it's there. This current is divided mainly into four main parts. First one is capacitive part. This insulator is subjected to two different voltages from both sides. It will act as a capacitor. Whenever we have a medium enclosed by two plates, each plate has different voltage, there will be a capacitance. This will be a very fast current. It will rise in almost 10 seconds, and it needs maybe 60 seconds to decay completely. So for this component, the capacitive component, we need to wait almost 60 seconds for this current to decay out completely. Second component is the conductive or resistive component, which is applied for any material in this world. Third component is the surface current component. Normally, the insulation material, whether like this plastic, PVC, XLPE, or porcelain or glass, whatever, it will have a kind of dust on the outer surface, and this will absorb part of the current for also a short period of time. Fourth component is the polarization component. Any insulation material is hygroscopic in nature, means there are some dust or moisture inside this material. So when there is an electric field applied to this material, the particles of the moisture and foreign materials will align themselves with the electric field. This alignment needs some electric current. This also will be for a short time, and it might take up to 10 minutes. So back to the transformer. The transformer has the conductive parts, the windings, which are themselves insulated and separated from each other and immersed in the oil, which is also insulator. The high voltage windings are connected to the tap changer, which has taps, and then the terminals are brought outside the transformer tank and supported by bushings, which are themselves insulators. So this transformer system has to keep certain level of insulation, and we have to test this. So many factors which can affect the insulation level inside this transformer: the oil quality, the temperature, quality of insulation materials of the paper and the wood and the bushings, whatever. So how do we test this insulation resistance of the transformer? Before we begin the test, we have to keep in mind that this insulation resistance is temperature dependent. Whenever the temperature goes up, the insulation resistance goes down, and vice versa. So we have to record the temperature while doing the test. The device used in this test is called the meter. The meter is the same as the ohm meter found in any multimeter, but the range is different. For the meter, where the name is driven from mega ohm meter, since the insulation resistance is supposed to be high in the range of mega or even giga ohm, so this device has larger range than the ohm meter found in the multimeter. And this test is based mainly on the simple Ohm's law. This meter will inject voltage in the insulation material, and by measuring the current, which will be in the range of maybe micro or milliamps or even nanoamps, by dividing the voltage on the current, we can get the resistance of the insulation. To do this test for the transformer, the low voltage terminals will be shorted together, also the high voltage terminals, and there are three different measurements to be taken. Each measurement will be injected by different voltage, because the voltage we apply to the insulation material is always dependent on the system voltage. We can use 500 volt, 1 kilovolt, 2.5 kilovolt, 5 kilovolt, even more, based on the insulation level of the electrical system. So for the transformer, we are going to measure the insulation level between the low voltage and earth, high voltage and earth, and also low voltage to high voltage. And our transformer, which is under consideration, is 11 kilovolt to 400 volt. Low voltage is 400 and the high voltage is 11,000 volt. So after connecting the LV terminals together, the high voltage terminal together, one time we'll connect the low voltage terminals to the earth and measure the insulation resistance between the high voltage and earth. Next time we'll connect the high voltage side to the earth and measure the insulation level between the low voltage and earth. Then we'll disconnect them from the earth and measure the insulation level between the low voltage side and high voltage side. This is the connection diagram for measuring the insulation resistance between the high voltage and the earth. And this one is the connection diagram for measuring the insulation resistance between the low voltage and the earth. And this one is for measuring the insulation resistance between the HV side and LV side. And here are the results obtained from this test. And we can see from the results that we took the readings after 15 seconds and then after 60 seconds. Then we divide the 60 seconds one on the 15 seconds one, which is normally called the polarization index, to take into consideration the components that we mentioned in the beginning, like the capacitive, surface, or polarization component. And if the insulation resistance is more than 500 mega ohm, the results will be satisfactory. But as we can see, the results obtained are in the range of giga ohms. So this transformer will pass the test.